Welcome to Laws of Indices Level 5. Pause the video now, try the 4 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're told that r to the power of 2 over 3 is equal to 49, and we need to find the value of r. Now, since on the left-hand side of the equation we have a fractional power on r, we can use this law, which tells us that the numerator of that fraction is the power on r and that the denominator is the root. So this means that r to the power of 2 over 3 is equal to 49 can be rewritten as r to the power of 2 cube rooted is equal to 49. Now we can remove the cube root on the left hand side of the equation by cubing both sides, and this gives us r squared is equal to 49 to the power of 3, or 49 cubed. To now remove the squared on the left hand side of the equation and leave the r on its own, we can square root both sides, and so this gives us r is equal to the square root of 49, still with a power of 3 on it. Now, starting with the root, the square root of 49 is 7, because 7 times 7 is 49, so our equation becomes r is equal to 7 to the power of 3, and 7 to the power of 3 is 7 times 7 times 7, which gives us 343. So our final answer for problem 1 is r is equal to 343. In problem 2, we're told that 25 multiplied by 5 to the power of n is equal to 1 over 5, and we need to find the value of n. Now, in problems like these, and in order to be able to use our laws of indices, we need to write each value on both sides of the equation to a power of the same number. In this problem, we can see that 25 and 5 can both be written as powers of 5. So 25 multiplied by 5 to the power of n is equal to 1 over 5 can be rewritten as 5 squared, because 25 is 5 times 5, multiplied by 5 to the power of n is equal to 1 over 5. And we can write this as 1 over 5 to the power of 1. Now, looking at the left-hand side of the equation, we're multiplying together indices with the same bases. And so we can use this law, which tells us that we need to add their powers. So 5 to the power of 2 multiplied by 5 to the power of n becomes 5 to the power of 2 plus n. And on the right-hand side of the equation, we can use this law to rewrite 1 over 5 to the power of 1 as 5 to the power of minus 1. Since we now have the same base on both sides of the equation, which is 5, we can say that their powers must be equal to each other. And this means that 2 plus n must be equal to minus 1. To solve this equation, we can subtract 2 from both sides, and we get to our final answer, which is n is equal to minus 1 minus 2, which is minus 3. In problem 3, we're told that 2 to the power of t is equal to 1 over 64, and we need to find the value of t. Once again, to solve problems like these, we'd like to write the values on each side of the equation to a power of the same number. In this problem, we can see that 2 and 64 can both be written as powers of 2. So 2 to the power of t is equal to 1 over 64 can be rewritten as 2 to the power of t is equal to 1 over 2 to the power of 6, because 2 times 2 times 2 times 2 times 2 times 2 is 64. Now that we've done that, on the right hand side of the equation, we can use this law to rewrite 1 over 2 to the power of 6 as 2 to the power of minus 6. And this is still equal to 2 to the power of t. Now that both sides of the equation have been written using the same base, which is 2, we can compare their powers and say that t must be equal to minus 6. And that's our final answer for problem 3. In problem 4, we're told that 4 to the power of q multiplied by 16 to the power of 2 is equal to 64, and we need to find the value of q. To allow us to use our laws of indices here, we need to write each value on both sides of the equation to a power of the same number. Now here, 4, 16 and 64 can all be written as powers of 2, but they can also be written as powers of 4, and so you have a choice as to how you'd like to approach this. I'm going to use powers of 4 and can say that 4 to the power of q multiplied by 16 to the power of 2 is equal to 64, can be rewritten as 4 to the power of q multiplied by, well, 16 is 4 squared, so 4 squared, still with a power of 2 on it, is equal to 64, which can be written as 4 cubed, because 4 times 4 times 4 is 64. Now that we've done this, we can see on the left-hand side of the equation that we're raising powers to powers. So we're going to use this law, which tells us that in order to simplify 4 to the power of 2 to the power of 2, we simply need to multiply the powers together. So our equation becomes 4 to the power of q multiplied by 4 to the power of 2 times 2, which is 4, is equal to 4 to the power of 3. Once again, looking at the left-hand side of the equation, we can see that we're multiplying together indices which have the same base. So we can use this law, which tells us that 4 to the power of q multiplied by 4 to the power of 4 is equal to 4 to the power of q plus 4. And that's equal to 4 to the power of 3. Now that we have the same base on both sides of the equation, which is 4, we can simply compare the powers and say that q plus 4 must be equal to 3. To solve this equation and find the value of q, we can subtract 4 from both sides, and we get to our final answer, which is that q is equal to 3 minus 4, which is minus 1.